We're on lesson 2 of chapter 3, which is properties of exponents. First we'll multiply powers with the same base, then we'll divide by the same base, and then raising a power to a power. Just a quick review, exponents are like this. 5 times 5 times 5. Since we're multiplying 5 times itself 3 times, we would do 5 to the third power. That's how exponents work. We have 5 to the fourth times 5 to the third. So when we multiply exponents like this, when their base is the same, that's important, they have to be the same like this, you can actually write it out like this. 5 times 5 times 5 times 5, that's 5 to the fourth. Then we need to multiply 5 to the third, 5 times 5 times 5. And then what you could do is you just count them all up. 1, 2, 3, 4, 5, 6, 7. So we'd have 5 to the seventh power. And that would be our answer, 5 to the seventh. A simple way of doing this, actually, if you notice the pattern, 5 to the fourth and 5 to the third, 4 plus 3 is 7. When you multiply powers times the same base, it's going to be equaling the sum of them. So for this example, I'm not going to type out a 24 times, but I will do a to the 24th, because 12 plus 12 is 24. And that would be the answer, because you add the sums when you multiply. Here we have the same base of 16, 16 to the first power, or just 16, and then 16 to the negative seventh power. So here we have 1 plus negative 7. So we'd have negative 7 wins by 6, so it would be 16 to the negative 6 power. And that would be the correct answer. Here we have 4 to the second power times 3 to the second power. And I can't do this actually, because 4 and 3 are different bases. Remember, it has to be the same base. If it's not the same base, it's not allowed. Here we have to divide now. Let's write the quotient as 1 power. To teach you how this one works then, we have 10 to the 8th divided by 10 to the 5th. If I'd write that out, 10 times 10 times 10 times 10, we need 8 total, and then that'd be over 10 to the 5th, so 10 5 times. Okay, then we could write this as a fraction, or like an unfinished division problem. And if we learn our crossing out properties from fraction days, remember if the number is the same on the top and bottom, we could just cross it off. So there's 1 that we cross off, here's 2, here's the third, here's the fourth, and then there's 1 more on the bottom then, and this would just become 1, right? So we'd have 10 times 10 times 10. So 10 to the third power over 1, or just 10 to the third power. And you'll notice that the rule is very simple again. When we were multiplying, we just added the 4 and the 3 together to get 5 to the 7. Here we're dividing, so we would be subtracting. 8 minus 5 equals 3, and that's the simple formula. Here we have x to the fourth divided by x to the ninth, so we would do 4 minus 9. When minus 9 is bigger than the 4, right, so the negatives win by 5. So you would have an answer of x to the negative 5th power. And there we have it. Here we need to raise a power to a power. So we'd have 7 to the 5th to the 3rd power. So 5th to the 3rd. That's a very, very complicated process, but the solution is very, very simple. When we have this kind of problem, all we need to do is multiply the exponents. So 7 to the 5th to the 3rd power would be 5 times 3. And that would give us 7, and then to the 15th power. Now we have 8 to the 9th to the 11th. Same thing, we just multiply that 9 and 11. So it'd be 8 to the 11 times 9, which is 99th power. And there's that correct answer. We have 2 to the negative 7th to the negative 2nd. So we would just multiply these then. So negative 7 times negative 2 is 14, so it'd be 2 to the positive 14, because 2 negatives make a positive. Then we have x to the 10th times x to the negative 6th. So if we're going to multiply these, a positive and a negative, that makes x to the negative 60th for our answer for that.